Alright, this video is going to take us through the Chapter 6 study guide so that you are ready for your test tomorrow. So if you look at number 1, it says list the ordered pairs shown in the mapping diagram. So your mapping diagram is just essentially an input-output table. Okay, so remember your input values are your x, your output values are your y. So I'm just going to write these ordered pairs right out here to the side. And you just pair whatever x goes with the y. So this first one would be 0, 4, 1, 6, 2, 8, 3, 10, and 4, 12. Again, I just did whatever the x was pointing to over in the y column. For number 2, same thing. Okay, this time we have 1 paired with negative 3, 3 paired with negative 1, 5, negative 8, 7, negative 9, and 9, negative 9. And those are your 5 ordered pairs. For 3 and 4, it says find the value of y for the given value of x. So number 3 says y equals x minus 5, and they tell you here x equals 9. So I'm just going to take this 9 and put it where the x is in the equation. So y equals 9 minus 5. So y would be equal to 4. Okay, same thing on number 4, y equals 4x. So again, I'm just going to take what x equals, which is negative 7, and plug it in. So we have y equals 4 times negative 7. So y would equal negative 28. Okay, number 5, write an equation that describes the function shown by the table. So whenever it says write an equation, it's basically just wanting us to figure out the pattern that's going on. So 0, 0, that really doesn't tell me anything. 1 to 5, 2 to 10, 3 to 15, 4 to 20. You should notice that it's just multiplying by 5 each time. So to get y, we'll always start with y equals. You have to take your x value and multiply it by 5. So we write that as 5x. Okay, moving on to number 6. Write a function rule, and again, that's basically the same thing as an equation. So write a function rule for the statement, the output is 4 less than the input, and then complete the table. So remember, with these, we just write exactly what it says. The output, that's your y. Is means equals. 4 less than. And remember when I told you if you ever see the words less than or fewer than, it does mean to subtract, but it's actually going to be backwards than what the problem says. So instead of this being 4 minus the input, it's going to be the input, which is x, minus 4. So there's my equation, or my function rule. And now I just need to fill in the table. So I'll just take whatever x is and subtract 4. So 1 minus 4 is negative 3. 2 minus 4 is negative 2. 3 minus 4 is negative 1. 4 minus 4 is 0. All right, for 7 and 8, it says use the graph or the table to write a linear function that relates y to x. Basically, all we're doing is writing an equation again. Okay, so for number 7, since it's a graph, remember our form y equals mx plus b. Okay, b is your y-intercept. Where does it cross the y-axis? So if I draw a line through here, okay, I notice that it crosses the y-axis right here at 2. So wherever that b is, I'm going to put a positive 2. Okay, still have y equals. Now I need to figure out m. What's the slope? So remember, to find the slope, we do rise over run. So pick any 2 points you want. Let's say we do this one and this one. Okay, and to get there, I would have to rise 2 and run 1. So 2 over 1, which is just 2. So there's your equation, y equals 2x plus 2. All right, on number 8, okay, again, we're trying to find the pattern that's going on here. You could plot these points and then do exactly what we did on number 7, okay? Or we could just figure out what our slope is and what our y-intercept is and plug them in without doing the graph. Now, one thing I want to notice right here, the point 0, 0, that means that your y-intercept is going to be 0. It's going to cross at 0. So then we just need to figure out our slope. So remember, to figure out our slope, if we don't have a graph, we subtract the y's, subtract the x's, and you can use any of these points that you want. So let's say I'm going to use these right here. Subtract the y's. Okay, I would rather do 8 minus 4 because it'll give me a positive number. But if I do that, then for the for the x's, I would have to do 2 minus 1. So 8 minus 4 is 4. 2 minus 1 is 1. So your slope would be 4. Okay? And then again, your y-intercept is 0, so that b is not even going to be there. So your equation, y equals 4x. And you also could have noticed that just by noticing the pattern. You're multiplying by 4 every time. Okay, moving on. 9 and 10, graph the function. So we've been doing this for a long time now. Okay, again, plot your y-intercept first. So in this one, my y-intercept is a positive 1, so I'm going to come up to positive 1 and put a dot. And then my slope is a negative 2, which is negative 2 over 1. So I'm going to come down 2 and right 1. Down 2, right 1. You could do that as many times as you wanted. And then just draw your line there. Okay, for number 10, plot your y-intercept first. Well, there's nothing over here. Okay, that would be the same thing as like saying plus or minus 0. So our first point is going to be right at 0. And then my slope is 1/4. So I'm going to rise 1 and run 4. There you go. Connect those. And there you go. All right. Next part. Does the table or graph represent a linear or non-linear function, and explain? So again, on a graph, it's really easy to tell whether it's linear or non-linear. It's whether it's going to be a straight line or not. So on 11, you're basically just asking yourself, is it a straight line? And it's not. So this one is non-linear because it's not a straight line. Okay. On 12, is it a straight line? Yes, it is. So this one would be linear because it's a straight line. Okay. Now, 13 and 14, they're in table form, so you can't just look at it and say, oh, it's a straight line, oh, it's not. What you're going to look for is if there is some kind of constant going on, some kind of pattern going on. So on 13, if you notice, your x's each go up by 1 each time. Your y's go up by 3, then up 5, then up 7. It's not the same pattern going on every time. So this would be nonlinear because there's no constant. Okay, and again, you can write up in the table here. With the x's, we added 1 each time, but with the y's, we added 3, then 5, then 7. It's not constant. It's not the same thing you're adding every time. Okay, 14. My x's look like they go up by 1 every time. And my y's, subtract 2, subtract 2, subtract 2. So since that's the same thing, this one would be linear because there is a constant rate of change. Okay? All right, 15. Says the table shows the number of muffins baked in X pans. What is the missing y value that makes the table represent a linear function? Okay, so if you notice, my pans 3, 4, 5, muffins 18. We need to figure out what that question mark would be to make it linear. So let's figure out the pattern here. To get from 3 to 18, I multiply by 6. To get from 5 to 30, I also multiply by 6. So to get the number in the question mark, we would just have to take 4 times 6, which is 24. And that's it. All right, 16, last one. The graph shows the water usage for a business. Describe the change in usage from July to December. So here's July, that right there, and December would be right here. So they're asking basically what's happening to the water usage during this time. Okay, we can tell it's declining. So we'll say the water usage is declining at a fairly steady rate. It's not a constant rate because it's slightly curved. But it is fairly steady as you go through. Okay, so this is your study guide for your test that's coming up. So as long as you are good with everything we did on here, then you should be good for your test.